Hey everyone, I am absolutely thrilled you're joining us today for this explainer on AI memory architecture. We're pulling directly from some truly fascinating concepts laid out by the Anasup Consulting channel. If you've been following their deep dives into how AI models use and remember information, you know we're in for a really insightful session. Today, we're going to bring some serious energy to the data and break down two massive heavyweights in the artificial intelligence space, CAG and long context windows. Let's get right into it.
Okay, let's dive into this. How does an AI actually remember a 100-page document? Like, seriously, think about that for a second. When you upload a massive PDF, a legal brief, or I don't know, a whole code base into an AI, what is actually happening behind the screen? This is the invisible challenge of AI memory constraints. You see, it's not magic, right? It's architecture. And understanding this architecture is absolutely crucial to unlocking what an AI can actually do for you. Are you feeding it too much information? Is it forgetting the important details? Well, we're going to find out exactly how dynamic recall works.
All right, here's our quick roadmap for today's explainer. Section 1, the AI memory challenge. Section 2, decoding CAG mechanics. Section 3, inside long context windows. Section 4, the ultimate matchup. And finally, Section 5, navigating your AI strategy. We're going to impartially break down both contenders so you can see exactly what makes them tick before we compare them.
Section 1, the AI memory challenge.
Okay, so AI models need efficient ways to store, retrieve, and utilize vast amounts of information dynamically. I mean, why does this matter so much? Well, as we demand more and more from AI, like asking it to analyze complex medical records or parse years of financial data, the evolutionary need for models to handle this complex data has just skyrocketed. Literally, if an AI can't hold the context of your conversation or the data you just fed it, the whole thing falls apart. It hallucinates, it forgets. So this fundamental hurdle has led brilliant developers to two very different but very powerful architectural solutions.
Section 2, decoding CAG mechanics.
So our first contender, CAR. This stands for Context-Augmented or Context-Aware Generation. Basically, it's a targeted approach where the AI retrieves only the specific, relevant information needed to answer a query. To really wrap your head around this, imagine your own memory as a highly organized filing cabinet. When someone asks you for a specific client's phone number, you don't read every single file in the cabinet from A to Z, right? Of course not. You walk right over, pull the exact folder you need, and give the answer. That's CAG in a nutshell. It's incredibly precise and keeps the AI focused exactly on what matters without overwhelming its processing power.
Let's move to and see how this builds procedurally. Step 1, analyze the user query. The AI figures out exactly what you're asking for. Step 2, search the database for relevance, basically scanning its indexed filing cabinet. Step 3, retrieve specific context, pulling out just the necessary snippets of data. And finally, Step 4, generate an augmented response using those targeted snippets to give you a highly accurate, grounded answer. I absolutely love the procedural nature of this because it scales so beautifully. You could have millions of documents, but the AI only ever reads the few paragraphs relevant to your prompt at that exact moment. Brilliant, right?
Section 3, inside long context windows. Now, enter long context windows. This is an entirely different AI architecture that allows the model to ingest, hold, and process massive, unbroken blocks of data simultaneously. Okay, so if CAG was our filing cabinet, long context is like having a flawless photographic memory where you can hold an entire library in your head, all at the exact same time. Actually, scratch that. It's more like instantly downloading the library into your active brain. You aren't searching and retrieving small pieces anymore. You're literally looking at the whole picture at once. Every word, every sentence, every single page is held directly in the AI's active working memory. And this brilliantly illustrates the sheer scale we're talking about here. Massive token ingestion scale. We are talking hundreds of thousands, sometimes literally millions of tokens processed in a single unbroken go. The brute force elegance of this is just incredible. By absorbing everything at once, the AI can see broad patterns, spot subtle connections across distant chapters, and grasp complex holistic structures that a piecemeal retrieval system might just completely miss entirely. It is heavy lifting on a massive scale. Section 4, the ultimate matchup. Now, what's really interesting about this slide is seeing them head-to-head. On one side, we have CAG, targeted retrieval, highly efficient memory usage. On the other side, long context, comprehensive data ingestion, brute force processing. And, neither of these is universally better. It entirely depends on the job you need done.
CAG is incredibly cost-effective. It's fast, and it's perfect when you have an ocean of data, but you only need a drop of truth. Long context, on the other hand, is a total powerhouse when you need the AI to synthesize a massive document as a whole, like summarizing an entire novel or finding a contradiction hidden between page 2 and page 98. They just handle information fundamentally differently, and both are completely vital.
Section 5. Navigating your AI strategy.
So, the crucial point is how you actually choose the right dynamic recall method. If you're following the insights from Anasup Consulting and building your own tools, here's what you do. First, evaluate your data scale. How much info are you actually dealing with day to day? Next, assess the need for specific retrieval versus holistic synthesis. Basically, ask yourself, do you need to find a needle in a haystack, or do you need to understand the whole haystack? Ultimately, it's a balancing act. Optimizing for your specific use case by weighing cost, speed, and accuracy will always dictate whether you build a targeted CAG system or leverage a massive long context window. Structured thinking leads to better AI.
Which brings us to our final question. Which memory architecture will drive your next AI breakthrough? The way we manage AI memory isn't just some boring technical detail. It's the very foundation of how intelligent, accurate, and capable these systems will become. So think about your own projects right now. Are you building filing cabinets, or are you creating photographic memories? Keep exploring, keep learning, and keep building. I really hope this explainer clarified these powerful concepts for you. Thanks for joining me, and I'll see you in the next one.